Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. Yesterday, we worked out some information about sorting that we think will help us sort of put. Well, I guess I should say it's our first attempt at putting to bed our long-standing sort of Z situation that we wanted to clear up before we start the regular game code. And I don't really know if we've completely solved the problem or not, but we came up with, sort of one plausible sorting criteria that might work. And there's two things about it we don't know. One is we don't 100% know, like I don't know that I definitively proved that it's always going to be the correct sort for us. I think I, was properly thinking through the cases that we're likely to encounter, but, maybe there are cases that we are definitely going to encounter with our sprites that I just didn't think of, right? So that's one possibility where we can't say for sure that we really know that it works. The other possibility is less about the sorting criteria and more about the sort that needs to be implied with the sorting criteria. I think it might be possible, I at least have a feeling that it could be, a plausible case that we can produce a non-topological result with our sorts, meaning the sort criteria that we picked is not guaranteed to produce a total or partial ordering that's consistent. And so running a regular sort routine on it, like merge sort, may not actually be able to properly resolve the sorting, even though our rule is sound. It may turn out violating that. And it's pretty easy for us to verify that fact, so that's kind of actually something we might want to do, right? Because what we could easily do is run an n-squared algorithm after the sort, only in a special debugging scenario, that goes and compares every sprite with every other sprite via our sorting rule, and alerts us if any of them return the wrong sort order, right? So we do our sort with our merge sort, then we compare every pair in the n-squared way and go, are any of these sorts wrong in this list? And if they are, then we know that we did, in fact, hit that case where we've produced a non-topological, or a thing that cannot, whose orderings cannot be properly solved by a regular straightforward sorting routine. And if that's the case, then again, that's really not a death knell for us at all. That just means that we would have to escalate our solve from a regular sort to something a little bit more graph theoretic, like the kind that Andrew Russell talked about in the blog post that I showed yesterday that he wrote specifically for us, which was very nice of him, about how he was trying to do sorting on River City Ransom Underground, where he just decided that because of the way that their sprites were, there was no choice but to use a semantic understanding of what was in front of what, which leads to a clearly non-sortable set. It's a set that has to be sorted as a graph. And so we might be in that category. We don't know yet. If we are, it's not the end of the world. It just means we'll do a graph sort. And that's totally fine. But we certainly don't want to do a graph sort if we don't have to, because a graph sort will probably be slower than a straightforward merge sort. I don't know that that's necessarily true because we haven't really looked at it. But it's probably the case that we would want to stick with being able to do a more straightforward sort if we can. So that's just what we're doing so far, and then we'll see as we get a little further into it whether we hit either of those two cases. We should be able to see that once we start testing it out in some real-world scenarios, does it do sorting the way that we think it should, or are we running into problems where it's just not producing the kind of sorts that we think should be happening? So let's go ahead and open up here. Open up. So one of the things that's true is we wrote the sorts and they're compiling, but as you can see if we run the program, it's not actually running the sort right now. So nobody calls the sort. We wrote the sort, but it's not actually being called. So it's still just running the old thing, which isn't what we want at all, and is doing some old stuff as well. So today's objective, really, since the sort's already done, except for one thing, I think Steven, Quartertron, I think on the chat, he pointed out something that is a mistake. I forgot to flip the signs here when we did both Z sprites. what I wanted to do was say, you know, if the ymin is not equal to the ymax, I think, well, actually, you know what? He was tweeting at me that there was a problem here, but I don't know if that's true. If they're both Z sprites are ones that have a bound. So I don't know. I think this is actually correct. If this is not equal to that and this is not equal to that, then they're both Z sprites. Otherwise, one of them's a Z sprite and the other one isn't. Right? I'm pretty sure that's the case. But yeah, I could be wrong about that. Seems right to me. Anyway, I'll let you guys figure out whether it is or it isn't in the chat, and then we can always go from there. What's going on? How come I can't... Whoa. What's going on here? My keyboard's messed up. There we go. All right. So here's our merge sort that does the sorting that we actually wanted to have done. And what you can see here is it takes this sort sprite bound in. Now, there's some things about this that are kind of interesting. And I don't actually know how much we want to take advantage of this, but it's something to think about here. So in addition to the ymin, the ymax, the z and the zmax, we've got this the index, which is the thing that we were going to be drawing. What occurred to me is that the z values we could insert fake planes essentially that are there to be our layer dividers. And what we could do potentially is actually get sorting into layers for free out of this, I think. Because if you think about what's going to happen with this sprite sorting, we're going to end up sorting by Z as you know, as a criteria for the sort in addition to everything else. And if we have a situation where we had something with infinite y bounds, right? Then it would always sort by Z. So if we stuck in a giant infinite plane, essentially, in between each layer, that would automatically sort everything below it or above it, so into like sort of two groups. And we would know as we retired things, we would get to those little plane markers as we were retiring render instructions, right? So that's just something to think about, and it kind of seems like the sort of thing we might care about. If we go back up here and take a look at the sort entry information, and then we look at the sort sprite bound, what we want to do here is sort entries we probably want to leave because we were sorting other things, right? We were using the sort, for example, to display the top performance eaters on our profile. So we want to leave this case in here, right? We want this to still be active. And so I'm not going to touch that case, but what I am going to do is probably turn the whole renderer over into using sprite-bound sorting so that now we can start to push things into it that will actually use that information. And so the challenge here is not going to be doing that because that's not going to take very long, I don't think. It's really just a case of swapping them out. The problem is that we don't have a lot of this information at the immediate moment, and so what we're going to have to do is actually start going in and figuring out where is that information going to come from. And obviously for our straight up and down cards, you know, one of the things that I think we luck out on by if we can get away with this sort criteria. One of the things that you can notice here is that, well, for our straight up and down cards, we don't really think we need a lot of information about the y-bounds, so we can just ignore the y-bounds entirely and leave them as straight up and down cards. That's what the sort criteria allows us to do. So hopefully the only things we really need to mark up are these these like flat tiles, and those we actually kind of do have an idea of what their bounds are, because since they are ground tiles, we know they take up one ground tile's worth of space, which gives us what their actual y extents should be. So hopefully, if we're lucky, getting this information into the renderer won't be particularly onerous, because we will be able to do some fairly straightforward stuff here, I hope. I don't really know, but that's my hope. All right. Okay, so let's get started on this. See where we get to. So we've got our render group, and mainly what happens here is when our render group pushes things on, I believe that, you know, first of all, the sort key information when we're doing our entity basis p result stuff, that's gonna have to change a little bit, because now we don't sort of care about the sort key anymore. We really just care about what the max z value is, and that's a value that's going to get transformed in probably, I don't know, is it? I guess that value doesn't really have to get transformed all that much. It just has to get put relative to the camera, I think, is the only thing that we really care about there. Well, actually, even that's not true, because since there's nothing behind it, really we can just use, I think, the z value straight up. So we may be able to get away with not really having to do anything with the sort keys here at all. I don't know if that's true, don't quote me on that, but if we're really lucky, we may be able to excise sort keys entirely from the entity basis results. That would be really lucky. Let's not push our luck and say that it's going to be true. Let's just say that would be great if it happened. In the meantime, let's focus on what's actually known here, which is that in our code before, where we were sort of doing this stuff where we're pushing in these sort of sort key entries, what we're going to do now is just change that, and I'll just go ahead and look for that here. Where is our sort entries? I thought they were in here, but I guess they're not at the moment. Render group, sort entries. Looks like we don't talk about those in as many places as I thought we did. But yeah, you can kind of see them happening here. So anyway, here is where we actually push our render element. And everywhere that we're talking about a sort entry in here, we really want to now talk about one of these alternate kinds here that we have, the sort sprite bound. Right? And so what I'm going to do is I'm just going to take this piece of code here, and I'm going to say, everywhere you were talking about a sprite entry, let's talk about a sort sprite bound instead. Okay? So now we've essentially got the same thing. We're pushing sort sprite bounds down from the top. They're a little bit bigger. They're about twice as big, but that's it. So it's not too big. It's not too bad. But it's obviously not great. Anytime you expand something like that, it's not fabulous. But what are you going to do? So now that we have that information there, when we push this information, when we do a push render element, we're going to actually need to push in what we think the sprite bound actually should be. And so that's the real place where this gets a little trickier, right? So here's our sort sprite bound that's going to come in here, and that needs to get written into the buffer for that future sorting. So instead of sort entry sort key equaling sort key in this case, and index equals command, well, actually, I guess, yeah, now I think about it, we don't need to copy the index part. So I don't know what we want to do here. I don't know if we want these guys to be... well, let's do it this way, and I don't know. I don't really want... I don't love the fact that this is something that's got an additional element to it that doesn't actually need to be passed in, right? Because you can see that this index here is going to get set inside the push routine, because it's the thing that knows where the actual entry is, right? And so that index is telling you the offset into the push buffer where the actual operation goes. But if we take a look at the sort key side of things, I was saying I wanted to make it so that I could just pass in the entire bundle. And so the question is, do we want to pass in this ymin, ymax, zmax thing as some kind of a separate sort of value? And that would look like this. That would just be like, okay, sprite bound or something like this. And sprite bound would have, these three values in it, and then this would just have the sprite bound in it as a separate thing, right? Or something like this, where it'd be the value. And in fact, I guess we could say that that's the sort key in some sense, if that makes sense, right? So we'd be passing the sort key, we'd still set the sort key, but now the sort key is this sprite bound thing, and off we go. Now, if that's the case, then that means in here, like every time we were sort of looking at these particular things, when we do sort sprite bound A and sort sprite bound B here, what we're really talking about now is, well, you really don't need the indices. So actually, when you're doing is in front of, you're talking about just passing those two things separately. And then when we're doing those is in front ofs here, we would just say like, oh, you know what, why don't you pass the sort key instead? And really, also similarly, this could be made clearer to the optimizer probably by just saying, hey, those are objects. You don't have to worry about aliasing. You don't have to worry about writing to them. Now, it should have been able to figure that out itself, but I don't know. Sometimes I like to turn things into pass by value just so the optimizer knows what's going on here. It just avoids any possibility of confusion when it does that substitution of the inline. I always get a little nervous about it because I think it slows us down in debug mode, which I don't love, but that's just the realities of People don't care about the game industry when they make their compiler. All right, so anyway, all we need to do is just pass the sort keys there, and there's one more call down here to it, right? There's two cases where we care. There's the merge part and the part where we're actually doing just two entries. So if I go ahead and pass the sort key in both cases, then I think I'm good to go. Now, obviously, we've got a problem in our outer code, which is that now that, ostensibly, we've effectively, we've made it so that now all we have to do is go out to the render code and tell it to use the other sort, and we're good to go. But obviously, we kind of have a problem here where now all of the code that was previously calling these guys, and it was passing in, some notion of a sort key, it's always wrong, right? We now need to give it more information about what these values actually were supposed to be. And so when we do a push bitmap call, if you think about it, we really now don't have any idea what those values should actually be. And that makes things a little tricky. It means we kind of have to go like, all right, what kind of bitmap was this and all that sort of stuff. We have whether or not the thing is upright set in the object transform, so that is something. And we could probably try to figure out something like what the min and max values of certain elements are based on the sprite size, but yeah, it's a little hard to say. Let's think about this for 1 second. So, yeah, I mean, in theory, what we could do, and I don't know if this will work properly, but in theory, what we could do is say, use that object transforms upright versus not upright, use that to determine how to interpret the bounds of the bitmap, and then use those bounds as just straight up modifications on the values. I don't know if that's good enough. Like, I don't know if that's going to work, but maybe that's what I'll try for the sort, and we'll just see what happens. Sometimes you just cross your fingers and try something, and then you let what actually happens inform you as to whether that was something that's workable or not, right? Okay. So what I do know is that would, let's start with the obvious stuff, which is that now we've got this notion of the sort key it's just done, right? Because one thing we know for sure is we can yank all the existing sort key stuff straight out of here, because even if we need to do some other computations, this ain't it, right? So we know that this all goes bye-bye, right? So that's gone. And so we can eliminate all of that and let that guide us with now how that's going. So we're passing sort of these pieces of sort key information from the dim basis stuff. We don't want that anymore. So when we actually get the bitmap dimension back, the object transform has that where is that guy? There it is. We have that upright there. And like I said, we even have a to-do there that's whether or not we want that to be in the object transform or not. And again, I don't know whether we want that in the object transform or not. Maybe it needs to be in a different place. Maybe push bitmap needs to take it as a parameter. I don't know. But what we do know is we need that value, because one of the things that we said that's crucial to our sort criteria, we could not get around it when we thought about it, there did not seem to be a way to get around it, is we need to know whether something acts like a ground tile, so it's effectively flat, or whether something acts like an upright tile, so it's effectively vertical. And in the case where it's upright, we know that we don't need to set those y-extents, we just need the z-max. And so in the other case, we need the y-extents, and the z-max is just whatever the z-value actually was for that sprite, right? Okay. So let's take a look at that. So when we go to do that, we know that we've got this sort of sprite bound. And the sprite bound is going to be set in one of two different ways. So one is sprite bound ymin, sprite bound ymax equals some value, right, which is the y value. Now, if the thing is a card in y, then what we would know is that whatever its actual y value is, just wherever it actually is in y, and in 3D y, like where it is in the three-dimensional y coordinates of this thing, that's our sort, just straight up, right? Because we know that it's only a card that's vertical. It can't ever have a different y value than the one that is its position. It's always straight up and down. So we can take the offset plus the object transforms position, right? So we can take the object transforms y plus the offsets y, and we know that that's what it is. So that's really easy to set. What's harder to set, and again, this is if it's upright. So this is if the object transform, if we're talking about an upright sprite, right? What's harder is that Zmax value. Because the Zmax value is the highest point on the sprite, so we know, obviously, that we start out, you know, here. But we know that we're going to go by a certain amount of scale, that height, we're going to actually expand out the size of this thing, right? And so what I'm thinking is that if we take a look at what happens in get bitmapdim, when we pass that height in there, you can sort of see what's happening here. We do a height times width over height. Here we get that size, and we're taking the size and we end up blowing it out to basically be centered around its whatever its alignment point is. And then we sort of figure out where the sprite is around there. Now, what you can see when this happens, we get the size and we get that alignment. What we kind of want to know at that point is, well, we want to know this piece of information right here, sort of, right? We want to know what the highest point is going to be if we were to sort of go upwards by that amount with sort of this... The y-axis in this case is really the z-axis, right? Because the sprite is standing upright in z is kind of the idea, right? And so I don't actually know what I should do to get that out in the most convenient possible way. And the fact that the sprite can be rotated definitely doesn't help. But what I think I'm going to do, just to make things a little simpler, is for right now, I think I might just say, let's take whatever the height of the sprite should be, and we'll say you go half that up. Now, what that doesn't take into account is where the alignment point is, so it's not really quite correct. And I feel like that's probably something we'll have to make a little bit more accurate in the future by going, okay, let's see now, how are we actually rotating the sprite perhaps, or where is the actual alignment point? And I could, you know, I could do something a little bit fancier here. Obviously, you can see where the dim size and dim align come back. I guess now I think about it, I could certainly take dim size and dim align and make those be a little bit more accurate here. Maybe I should. So if we take the dim p x y and you take a look at what happens here, the y that comes out of that is basically going to be, I think, the y that we want. Well, it's going to be the bottom corner. Depending on how it's rotated. I say. I think I'm going to put a to-do in, and I'm just going to do the easier thing first. So I'm going to say to-do more accurate Zmax calculations. This doesn't handle alignment, rotation, or axis shear scale. Because really what we want to do is take the maximum of the bounding box of the rotated entity, which, again, it's just a little... There's a lot of fussing. So I think what I'll do first is say, well, for people who are not doing any of that fanciness, then we pretty much know that if you were centered, you would be something like this. So at most, we'd be off by 0.5 of that height. So I'm just going to let that be a temporary sort key, and we'll see how that goes. All right, so in the other case, we have the exact opposite problem, right? In the case where we have something lying flat, then what we have is we know that the sprite-bound Zmax, we know it exactly. It's just this, right? Because we know that the sprite is constant in Z, so we know that its Zmax is just whatever the Z value of this thing was, because it's flat in Z. But what we don't know is what are its extent in Y. Now, we know where those extents might start, right? Because we know that it sort of has a Y value that's, centered around this potentially, or is related to that. But we don't know how much to add to the Ymin and the Ymax to actually get it to sort of flow out to that entire size. So the question is here, how much do we want to do that by? Again, we could do exactly the same thing here, potentially. But we're probably going to have to be more accurate than this, I would suspect, in the future. So again, this probably won't give us right results, but we can start with it. And so here we'd just be saying, well, the minimum y would just be however far back height, and the y max would be however far forward in height we would go. And for something that was simple and not doing anything more complicated, that would probably be correct, I think. But I think these are inaccurate enough that I suspect we will not get through the whole game with those holding. So after we sort of get things working, we'll probably have to go back and go, see, yeah, it doesn't really work here, and it doesn't work because of these sort criteria, so now we kind of got to go do the more real stuff. All right, so that's our push bitmap call. And once we have Sprite bound, now we can just pass Sprite bound to this, and off we go, right? Now, what we probably want to do here, well, I guess let me finish this stuff off. So, yeah, what is the object transform? It's offset P. Oops. Yeah. And in some sense here, we can probably also take advantage of just a little bit of the commonality of the code here and just say, well, okay, so the ymin is always that and the zmax is always that, effectively. But then what happens here is like, oh yeah, you add in this in the case where you know that you're an upright sprite, and you add these in the case where you know that you're a flat, lying down sprite. Seems reasonable. So all right, so moving along, we've got a push rect situation here that I think, and I'm not entirely certain, but I think we can just sort of use the exact same code, would be my suspicion. So when we're like doing something like push rect, I think we should be able to effectively use the exact same calculation. I don't actually know that that's true, but that's my suspicion. And so now we've got the same situation with clear. If we want that to sort to the bottom of the screen, then what we would need to do again is sort of use that fake planar idea I think I was doing before. We could say we've got a sprite bound, and here's our sort key, and that sort key, well, sort key min ymin equals real 32 minimum, sort key ymax equals real 32 maximum, and then sort key zmax equals real 32 minimum. And that'll sort, I think, below everything else that exists, so that will still satisfy the same criteria, I believe. Famous last words again. But anyway, so now that we have that information, what we need to do is we need to do two things. First of all, we need to find a way to share this particular code right here. And so let's see if we can pull that out into something where we can say, okay, sprite bound, get bound for, right? If this was something that had to be called as a separate thing, how might we do it? Well, what do we need? We need two things. We need the object transforms offset P and the upright, right? And then we need the height and the offset. So three things. So we need the object transform, kind of like the Spanish Inquisition. So we got the object transform. We also need the height. We also need the offset. But I think with all of those things in place, then that's pretty much all we need. So then we can just say like sprite bound equals get bound for, and then we can just pass it the object transform offset height. Oops, not so good. And then we can compile, and I think we're good. So now we've got our sort key stuff, I think, under control there, and should be able to just, like I said, kind of copy that over to the rectangle case when we do a push rect here. So there we go. And now the only question is, well, what's height? Well, height is just the y dimension. I think that's all we really need to do there. And then we can pass that as the bound. Okay, so now if we run this, we're going to run into a world of hurt, I suspect, very quickly, like you can see. And the reason for that, of course, is that our renderer doesn't know that we changed the format of our sort keys. So we're going to have to go tell the renderer that that's, well, not okay. So if we go into the, let me see here, if we got our sort entries. So here's our sort entries command, right? And it's going to pass that sort memory game commands thing. And you can see it sort of pulling this information out here. And you can see that when we grab those sort entries out, you can see that it casts it to a sort entry there, and that's just because whoever sorts the entries, that's what they wanted to do there. Yeah. So what we need to do is make sure all of these people start using the correct the correct thing for sort entries. Now, what it occurs to me that we didn't do particularly well here is you can see that we've got this sort of notion that everyone can just cast this value. Now, that's not great because now, you know, if you imagine that we had this in 20 different places, well, I wouldn't really have any way to make it easy for me to know that that's what was happening. So when I do a cast like this, what I probably should do, and you can sort of see why hopefully this would make some sense, is I think probably what we want is inside the code that's shared in the renderer that's doing that sort. In fact, maybe I could put that in sort.cpp here. What I could do is say, well, all right, let's make this a more like standard operation. So we know that, you know, when we go to do our sorts, you're going to call this routine, and that way if the sprite bound thing changes, then you know that it was supposed to be different. So we've got this sort of concept that we're returning a sort sprite bound, and we would say get sort entries here, and then it would do just exactly this. And again, there's nothing weird happening here other than the fact that we're just kind of cleaning up that notion that what you're returning is a particular type, right? That's all I'm trying to do. And so that would take the commands, so that would take the game render commands. And now, you know, we would say like, oh, okay, let's go ahead and get those sort entries out. And we just say the sort sprite bound, in this case, as opposed to sort entries, is going to be equal to get sort entries for these commands. Off we go. And so now that's all good, and you can see that that will cascade our errors down. But of course, we've got our OpenGL renderer as well, and it's doing the same thing. So what we want to do here is make sure that it also uses the same code path. So here we go, right? Just making sure that happens there. And now everyone should have cascading errors that help us correct it, everything to the right case. What just happened there? Okay, there we go. All right. So that's fixed now, but we still have one more place that isn't calling the right thing, and that's the thing that actually does the sort. You can see when we call sort entries here, it's still thinking of this in terms of sort entries. So what we would want to do again is if we had this had been doing the correct call in the first place, right, it would have immediately given us an error. And that's the only reason I want to do that, right? So now that anytime I change that, since that is a cold cast, now it's going to be better, right? Okay. So now when we actually get here to do our sorting, obviously like this, the radix sort, not an option anymore. So that's like totally not okay. So we're down to just being able to merge sort these guys, right? That's the only thing that we're going to be able to do. So let's go ahead and see if that's okay. What I don't remember what I just said the sort even took. So it takes a sort sprite bound start temp. How much space does temp have to have? So temp has to have the whole size, right? So yeah, so it's got to be effectively this size. Again, you can see the sort of cascading stuff here. Why I think it might be nice in case we want to make these sort of changes now that I've seen it happen once. The sort entries here, right, are also wrong because I believe we've got sort memory being allocated in here. So needed memory size is, yeah, you can see it doing like a size of sort entry here. So I feel like that's, again, the sort of thing where we probably want that to be clarified. And I guess, you know, inside the sort, maybe that, I don't know where that should go. Probably in here. That makes sense. And then probably like we want something in here that's like get sort memory size or get sort temp memory size. And that way inside the Win32 code, instead of it doing this, it can actually like ask and no, right? So it's going to say like, okay, here's the game render commands. And in that case, It's going to take the element count and it's going to multiply it by the sort sprite bound. And that really all I'm trying to do here, right, is nothing particularly complicated. I'm just trying to make sure that these operations kind of are all bound together in a reasonably close way, if that makes sense. So you can kind of see that, like, hey, everyone's got to do it the way that they do it, and if you change one, you'll know to change the rest of them. That's really the only thing that I was trying to accomplish there. It's nothing particularly fancy. So in here, we could just say, like, okay, get sort temp memory size for these render commands, and then get rid of the rest of this stuff. And then in here, when we do that get sort temp memory size, we'll return that with the needed sort memory size, and then I think we would be good to go. All right, so when we call get sort entries in OpenGL render, okay, so it looks like that's not, is that not in here for some reason? Shouldn't that would have to, because when it calls a sort, I guess it doesn't have to, I don't know. So maybe these have to be in the actual sort code, I don't know, let's find out. Sort entries, sort memory, when it calls the merge sort, sort sprite bound, sort sprite bound, there we go. Okay, and Handmade slow would also need to do this. So here is our, oh, so you know what? This is actually the exact test code we wanted too, when I was saying we want to test it more fully. So we can say, like, oh, make sure that is in front of, and speaking of is in front of, my head is in front of that. If is in front of is true for everybody in our, in our cases. So in Handmade slow, we can go ahead and do that, that test. You know what I'm wondering? Did this really never, I'm gonna test this. Because that's actually happening in our debug build. I'm kind of surprised that's not causing a problem. Is it timed function with a, is it just with a, yeah. Okay, so let's go ahead and run this and see where we're at now. So what I'm going to do here is I want to actually be able to step into this call. So I'm going to go ahead and see if I can rerun this statement, right? So that I can see what the actual sort comparison did in the case where I've already kind of got an error here. So here's two sprites, and oh, well, they happen to be the same, actually. So if we're sorting two sprites that are the same, then I guess the result could come out either way, right? So that doesn't really count. So I guess we would, oops. I guess we would say more like, okay, if it's in front of, then that's fine. If it's not in front of it, then we have to double check, are they equal? So we'll just assert entry A, sort key, ymin equals entry A, sort key, ymax. And this will then get us down to only cases where there are actually different sort keys and we can see. So, assume that we'll just verify that, oops. Verify that these are all completely equal to each other. So ymin, ymax, cmax, and these are all B's. All right, so now let's try and get an assertion and take a look at one that's probably more likely to be correct. Okay, so if we take a look at entry A and entry B in this case, they should be actually different values now. And it looks like they are, right? So their Zmax values are different. They are both, it looks like, upright sprites because they have exactly the same values here, right? They're both exactly equivalent. And so if we take a look at their Zmax values, we see that this one is 1.25 and this one is 0.75. So what we would expect to see is this one should have been sorted ahead of this one. And I think that's probably what we're not seeing here, right? Because entry A, entry A is coming first in the list, right? And entry B is coming after it. This doesn't actually do an n squared check. This only does an n check. Which is probably not what we want to check anyway. But it's good for our immediate checking purposes just to get the basic bugs out of the routine. So that's fine. Anyway, so entry A probably shouldn't be, right? Because if entry A and entry B are compared, then we should find that the Zmax value of entry B should put it ahead. So what's our actual index here? Our index is 70. So it does point to a problem with the sorting because it means that the first 70 entries were all sorted properly. And this is the only one that's actually wrong so far. Out of how many? Out of 2,000. So maybe, the other thing that we should do is probably look at what it's actually doing, which is kind of a separate issue here. So let me actually get this, zero this out just so I can actually see what's going on. Okay. Not great. Not great. Not great, folks. Don't love it. It's a blank screen. Okay. So probably what we're going to have to start with is something simpler. Like, I don't know that I want to try and debug 2,000 sprites stuffed into themselves there. I suppose one thing I could do is start with something that's in a set of discrete layers like the cutscenes. That might work as well. So we should probably take a look at that perhaps as our first order of business, because that would only have to ever sort in in Z. And we could verify that that was working properly. In fact, I think that's a good idea. So I think I'm going to do that. I'm going to do exactly that. What I don't remember is where I actually forced that to happen. I think it is in here somewhere. So I should be able to do this. And now I should get... come back here. I should get just the cutscene starting. Let me make sure that that's true. Yeah. Okay, so now let's start off with this. We should be able to sort of break in here and see what's going on. Let's double check that we kind of have this sense of these correct. So, is in front of, just by its grammar, A is in front of B. So we want to return it if A is the closer one, right? So let's just make sure that that's true. If we say to sort by Z, then we want to know that A's Zmax is greater than B's Zmax, because A would be in front, that's true. And Y would be the opposite set. So that is correct. So now let's go down here and make sure that this is in the correct way too. So we do our merge sort here. We say, okay, we've got our two entries. We're going to compare the first and second entries in the list. We're going to say if the second entry was actually supposed to be in front of the first one, we swap them. That seems correct to me, right? That seems like that's going to go in the correct order. So then we move down here and we say, all right, we're doing our sort of split merges, our two halves, we're splitting and we're merge sorting each of the halves. Then we have to put the halves back together. So we start through here and we say, all right, if we're only reading the first half, then we output it. If we're only reading the second half, then we output it, right? But if we're reading both, if we're still reading from both, what we want to know is which one of the two it should come first. So if read half 0 should come first, then we put it in there. If read half 1 should come first, then we put in there, right? And so that all looks pretty reasonable to me. Everything there seems fine. Then if we take a look at our is in front of, like I said, that seems reasonable as well. I think all of that looks pretty good. In terms of checking whether they're both Z sprites, both of the sprites would be Z sprites if they had Y bounds, which is what would happen here, right? They would both be Z sprites if they both have a Ymin and Ymax that are not the same. A includes B if A's min and max basically bound B, which is what it looks like here. And the same is true here. And we know that we don't have to check Ymax because Ymin and Ymax would be equal in the cases we care about, because both sprites would not be similar there. Now, I think that's about right. I suppose technically this might be wrong in certain cases where, I mean, not wrong, but inconsistent in cases where the Y's were actually equal. So it's possible that we would want to expand this out into something a little bit more specific. But that should all be fine for our basic scenario of sprites that are strictly in Z. And so what we should be able to do is we should be able to take our cutscene scenario and make a pretty clear, we should be able to get a pretty clear understanding of what's happening here. So let's take a look. So when we come in and we're about to do our merge sort, we've got 2 entries. That doesn't sound like enough. Let's run a little bit here. There should be more than 2 entries. There we go. So now we've got 39 entries. Honestly, that sounds like too many, but probably a lot of those are debug, I'm guessing. So in fact, maybe what I'll do temporarily is also turn off the debug. So inside handmade.cpp, just for the moment, I may go ahead and say where we were doing our debug out. In fact, I guess we do we have a convenient way to turn debug on and off? Oops. So Handmade internal would turn it off. I don't know if we really want Handmade internal off, but you know what? I guess for right now, let's go ahead and turn that off. So I'm going to go into the build.bat file. Looks like we're down to the 5-minute warning. Although I started a little bit late, so we actually probably more like 10 minutes. So if I come through here and say, okay, let's take Handmade internal off so that I won't get that debug. Now I should be in a situation, oh, looks like we are missing a few of our undef calls, basically. So debug begin data block. Needs to go away. Debug end data block. Needs to go away. Debug B32 needs to go away. And then what are these other guys here? Debug game frame end void function returning a value. I really need to get a version of 4Coder that can do the jump to error properly. I gotta email Alan about that because I haven't updated this one, but the one I have, the most recent one I have, still doesn't actually jump to error. The scrolling doesn't like quite work right on the newer builds. All right, so let's go ahead and take a look here. Debug game frame end void function returning a value. All right, so that just means get rid of it. Debug set event recording. Identifier not found. Okay, that's just, again, another case of debug set event recording. And off we go. So now we shouldn't be piling anything onto the drawing that involve, right? There's nothing else on the screen now. So we should just have a set of layers, and there we go, there's the 8 layers. We should just have a nice set of layers that's like, here's the things that we should be sorting. And this is the simplest possible case. We should be able to make sure that nothing super stupid is happening, which maybe something super stupid is happening. So let's take a look. So in this case, you can see we've actually got all of the Y values are set directly to very specific things. I'm not sure why those are set the way that they're set. So I guess the first thing I should figure out is why are those being set as having those y marks? Either way, if you look at these, it should be pretty straightforward how these z's would get sorted, right? I mean, that's pretty easy to understand because they all have z, so they're both, everything that's going to be compared is going to go through the both z sprites paths. We're always going to be comparing z maxes, so these z maxes should be sorted totally correctly, and we should be getting the highest z max. Well, that's a mini owl shame. We didn't really spend any time on it, so I'm okay with that. But hi, this is not a front to back renderer, right? I mean, that's kind of obvious. Let me put this check back in. So if you come up here to is in front of, you can see that we return is in front of correctly. Unfortunately, when we ask is in front of, we are then using that to move the closer thing up in the list. But a thing that's in front of another thing should be drawn later in the list, right? So actually, if A is in front of B, then we would swap them, right? Because so it's the other way round from what we had it in all cases, right? It's actually like that. So there you go. All right, so that's more what we were trying to do there. So now let's take a look at where we're at. Okay, so at least now we know that our fundamentals are not completely messed up. We are still able to produce the correct sort for a simple set of Z flat sprites. So that's good. Again, and I just wanted to, because this is a relatively touchy thing we're doing here, I wanted to make sure that we weren't totally messed up in some other way. So we know that that appears to be working correctly. So now let's jump back to the game side of things where stuff is going to get a little more squirrely and we can start to figure out where the rest of the bugs are. And also, like I said, we have to kind of determine that this sort even can be done as a straightforward sort, which I don't actually know if it can or not. So that's sort of a separate issue that we're going to have to determine as we go forwards. All right, so I'm going to put back in our jumping straight to the game without the title sequence. And now we can take a look at what happens here. Okay, so taking a look at this, what we can at least determine so far, and this is good, a good thing for us, what we can at least determine so far is we never fail our check in an obvious linear sweep, right? So that's good. We also have a bunch of interpenetrating objects here, so that's not great. But yeah, so the fact that we have a bunch of interpenetrating objects isn't fabulous for testing the sort, but that's something we can start working on tomorrow by actually giving it some more realistic stuff by fixing our sort of layer stuff. We sort of did these two things together as part of one go. Okay, so let's check just for the sake of argument as well. Let's say we didn't do that. So let's say temporarily that we went and went to world mode. And when we were outputting our entities, let's say that we didn't do our truncation stuff that we were doing that flattens everything down into the plane, right? I guess that's actually, I always make this mistake. I keep forgetting we moved it out to its own entity file. So when that's happening here, right, we've got this this notion that we're sort of doing our relative layer transform thing here. And we don't actually, let's say we don't actually want to do that. So we want to use the correct Z here. So we'll just actually let it draw the things in Z the way that they were going to draw the things in Z, just because I kind of want to see what it does with the sort in that case. So let's see. So it looks like in that case, I feel like it's wrong meaning we're not getting the sort that I would have expected. And the reason I say that is because you can kind of see that these things, I believe, should be... where's my... I don't have a mouse cursor, I guess. Oh, right, because Handmade internal turns off the mouse cursor. I can turn that back on for the moment. So I believe that all of these, right, these sort of closer up ones, I believe I'm standing on the further back ones, and maybe I'm wrong about that, and in which case I stand corrected, but I believe I'm standing on the further back ones, which means I should not be sorting, right? And you can kind of see, like, even, you can see that that's definitely the case, right? You can see as I'm sort of doing this that those should not be sorting the way they're sorting, right? I should be behind those, you know, there's a number of reasons why that could be, but those are what we'll start to address tomorrow because we're pretty much out of time today. So we've got everything running properly, and everything I think is sorting properly by the rule, but we now have to go see, are we feeding the rule properly? Because, you know, we got those janky computations in there for like Zmax stuff. And then also we got to start actually outputting these in a little more sensible of a fashion. So I'm going to go ahead and go to the Q&A, and then we'll come back to this tomorrow to get things sort of working a little bit more correctly, I think. Hello, Andrew. Good to see you here. Thank you very much for writing the blog post. I thought that was a really interesting blog post, even separate from Handmade Hero, because, you know, I'll be honest, I guess, you know, part of it's probably my fault because since I don't work on 2D games, really, I haven't, like, educated myself about what people generally do in terms of making sprites show up in the correct order, because it's an inherently, you know, sort of, it's an inherently semantic problem of like you know, this isn't real 3D. It's 2D plus you want to fake the depth. How do you do that, right? And so I really didn't know much about how people have done it, and I imagine there are you know, different approaches that people have taken in the past. And so it was really interesting just to read about that. I would be interested in reading about how other people are doing it too. Like I think that it would be kind of cool to just, now that I know it's not a completely trivial thing, right? It's not just, oh yeah, you just sort by Y and you're done or something. I feel like there's probably games out there that have done interesting things like the stuff that you were doing that I wouldn't have known about. And so I'm interested in that. I feel like it would be cool to find out how people are doing their sorting. So I really enjoyed reading that blog post. I thought that was great. And I really like the solution that you were using. It seems pretty cool. And I'm looking forward to playing the game too, because I think I haven't played a Double Dragon-like game in a long, long time. So Voucher, the coordinates used for the sort rules are world space, right? Would another approach be to sort the screen space coordinates from the top of the screen down? Previously what we were doing was sorting the screen coordinates, right? And the problem with that is that sorting the screen coordinates doesn't give us information about what to do in the cases. Well, I mean, it's pretty obvious why you can't sort the screen coordinates, right? Like, so the problem is, you know, you've got if I'm gonna draw like a 3D case here. So suppose I've got this sort of tile in the world, like a platform or something, right? And then there's something on top of the platform. When you look at that top down, you end up with this, right? And you have no idea. If the ball was below this thing, right, then in this case, if I was to label this A and this B, in this case, B should be drawn first, then A second, so it eclipses it. In this case, the opposite's true. But all you're going to see in screen space is that. So you have no idea, right? So at the very least, you would need sort of a screen space augmented with Z. So maybe when you're talking about screen space, you mean, oh, well, I mean XY screen space plus Z screen space, right? So in that case, you have a similar problem. And the similar problem that you have there is, well, now we start talking about, like, okay, we've got situations where, you look at something that's, trying to think of what the good example would be. Now you got something that looks like this. This is not a very good drawing, I admit that. All right. So now you got something that looks kind of like this, and you're viewing it from here, right? So what you end up seeing on the screen is you end up seeing something that kind of looks like this, right? Depending on how high up we're viewing it, right? And these two things overlap. Well, if now we're sort of saying, well, whoever had the higher Y sort value or the lower Y sort value draws first, which we would need to do to ensure that this guy drew first, then we have the problem that, well, people who are standing on top of these things, or even, in the case where we were talking about like a screen space rug, right, for example. In fact, that may be the better case here. Like we have sort of a thing that is on top of 4 different tiles. And then we've got somebody standing on that, which is the case we were kind of looking at before. So in this case, we have this nasty case of like, okay, when I actually go to look at this thing, I'm going to see this sort of thing happening here. Well, when I look at what's going on, this may well be, so the person who's standing on top of this rug may well be somewhere like in here. Whereas all of these things may be, kind of behind it or whatever, or there might even be one of them that's kind of sticking up, like over here, right? And when I start to try and use this as just a sort by Y, obviously isn't going to work. A sort by Y and Z, now I have to figure out, well, which do I use in these cases to sort of break the tie, right? Or rather, which am I going to sort by and how? Because I've got Y and Z now, and I don't know necessarily which one of which to use. If I strictly sort by Y, I'm going to get one answer. If I strictly sort by Z, I'm going to get another answer. How do I break the tie, right? Or how do I know which one to use? And as far as I could tell from, if you go back and watch my very sort of long ramble through this, as far as I can tell, the only way to really know which way to break the tie was to have the actual bounds in Y and use them. So you can't just have YZ, you need like Y min and Y max and Z. That was as far as I could tell. But you definitely can't just use Y, that's for sure. Whether you can use Y and Z with no Y bounds, I don't know, but I couldn't quite figure out a way to do it. And again, you can see me work all the way through it. Monday and Wednesday streams were all this. So you can go watch Mondays and Wednesdays and see me work it out, and as far as I could tell, you need this. You definitely can't sort screen space with no Z, because that doesn't give you even remotely enough information. Andrew Russell Net. I have a question about your development approach. I don't think I've ever seen you create a separate program or environment to test stuff. You always seem to work within the running game. Do you ever find this to be noisy? So I guess what I would say is it depends on the circumstance, but I usually find that the only times I want to be completely outside of the game environment is if I'm just doing a purely theoretical algorithm thing and I have a test bed already for that. Like I used to do that. I had a 3D thing called MathViz that I wrote that I used to use for making, for doing 3D algorithms when I was working on Granny at RAD. And I don't know, I don't think I've put up the screenshots from that since I... yeah. I don't know that I have those up here, but I had some screenshots of what that looked like, and I could go find them certainly. Well, point being, maybe I should go grab them on a thumb drive. I could show you. I guess what I'd say is I find that a lot of times that slows me down a little bit too much to do. But it's definitely been something that I have done in the past. And the way that I approach that is if I think I'm going to be doing a lot of work on a certain type of algorithm, like 3D algorithms, whatever, what I do is I make a little toolbox and a little system for playing around with stuff that I can use to sort of prototype things and draw things really easily. And so I do that sometimes. And you know what I just thought about? I wonder if this machine has any of that on it. I don't think it would have. Darn. Oh my, I got kind of excited about there because that's where it would have been. I guess this must have been, this machine probably got cleaned out at some point. But like, it would have been in my old Rad Game Tools source tree, and unfortunately that's gone. Like it doesn't come with the Granny SDK. It's just, it's just internal development stuff. So I don't see it here, and I guess all this stuff is just gone at this point. Yeah, so it must have cleaned out this whole directory, and then, but after having cleaned out the whole directory, it left all of the directories there, I guess. Cause like there's nothing on there. I do not know. Yeah, I don't know. I mean, it's like, I feel like I'm grasping defeat from the jaws of victory here. Like this would have been, I could have actually just run the program because it would have been here, but I don't, it does not appear to actually exist in any capacity here. Yeah. So much for that. But yeah, point being, there was a program called MathViz, and it you know. Andrew says, I realize I tell Di now I have seen you do something along these lines on Witness Wednesdays. Just less HMH. Yeah, I mean, another thing to remember about Handmade Hero is, I try as much as possible to show how actual game development works, to the extent that, like, I don't prepare for it and I don't try to think of the solution ahead of time and then just type it out, right? I try to actually, like, struggle with things accurately and be like, okay, I'm programming this, just sitting down, and if I have to work out something, I'm going to work it out on the, whatever. As much as I try to do that, there's also just the fact that some things I'm just not going to do. Like, I'm not going to spend, I think the original curve fitting algorithm for Granny, I mean, I probably spent, I don't know, 200 hours working on that thing. And so, like, something of that magnitude would have taken almost all the time that we've spent on Handmade Hero, just the whole thing, just on one algorithm. And so showing how that actually works just isn't super feasible, right? And so Handmade Hero is necessarily not going to show me tackling an ultra hard problem, because I don't think you could. Like, I don't think you could make a show where you did that, because what you'd see is so impossible for you to get through. And also, there'd be no talking. I would have to be thinking the whole time. So it's like, So I feel like I try to make it a fairly accurate representation of what programming is like. Coming up with brand new algorithms in hard researchy areas, we don't do on Handmade Hero, and I don't think you can do in the context of that. So your intuition that I don't seem to be doing that as much as maybe you might think I would is probably correct, in the sense that if I was working on some really hard problems on Handmade Hero, you would have to see me doing something like that. And probably those would be very long, silent, hundreds of hours of me sort of like, whatever. And so I think that's just kind of the nature of what you can and can't do in a series like this. I suspect that's part of it. So. Yeah, I'm sorry. I don't know if I've got. Let me see. I might on another machine have a copy of MathVis still kicking. I'll go look and see if I do. I probably don't, but give me 1 second. So let's see here. Success. So this was the program that I used for all of Granny development. And and basically the way it worked is it had like this sort of primitive UI thing that I'd written, and it's just a very simple UI. It's very similar to the kind of the approach we took in Handmade Hero, but it was made a little bit before I kind of got immediate mode UI, so it was a little bit like a halfway thing. But it's got sort of these like pretty simple sort of draggable slider things that you can throw in there to kind of edit things quickly. And then what you would do is it had this concept that you could like just drop in visualizations that you wanted. And I don't know how many there were. There were probably 10 or 12 or whatever. And I just zero some out when I was done with them. So they're not all in here, but you could compile in a bunch at the same time if you needed to. And then you could just basically click on them. And when you clicked on them, you would switch to that visualization. You can see me sort of doing it here. And so it had a bunch of tools in it. Like you could draw an arrow from one place to another. You could draw like a move manipulator. So this is like a, kind of like the kind on the witness, right? And you can see here, this was in fact, some of you may be familiar with that little thing, that thing I posted, which is like, here's how you solve GJK really efficiently and without all the really stupid math that I think a lot of people do who don't really know how the actual algorithm works. And this was the actual way that I figured that out, right? So here is the tetrahedral case. And so you imagine that the GJK has just taken a step in this direction and it found this as the maximal point. And you can see here that I'm highlighting the 3 points that I believe make up the correct simplex for the next step, which would be the triangle ABC. And you can see that I've like labeled them the way that I would have labeled them probably in the algorithm as well. And then what I would do here, right, is you can see how I would start to make sure that my code was working is I can drag the values and make sure that they actually switch at the times that they should switch, right? Does that make sense? Hopefully that makes some sense. So you can see that I'm like going like, okay, yeah, that case is pretty solid here. Well, actually, I guess I had to see this upright case, so there you go. Right, so I can see like, okay, so it's thinking that this edge is the closest now, and that seems correct, but as soon as I move this up till it's, or I guess I should say, till I move this up so that it's actually this triangle highlights, I should be able to see that, whatever, that kind of thing. And that's how I can play around with those and kind of see what's going on. Now, in this visualization, I'm afraid I can't probably give much of a demo because I don't think I remember what the heck this thing was. I'll be honest with you. It's some kind of a culling thing. You can see it must be a spatial partition because it's kind of, and there were usually keys that did stuff, right? And I don't know what those keys are in this visualization, so not much I can really do with that one. Here's an AABB, so axis aligned bounding box visualization of some kind. This looks like me testing this looks like I'm testing the Minkowski sum of a triangle, right? Like with an axis aligned bounding box, because that's what that looks like, right? Actually, I should say Minkowski difference probably, right? And the reason I was probably doing that is because like this was clearly compiled at a time when I was working on GJK, and so it's not surprising that's like, okay, I've got my axis aligned bounding box, and now we're going to talk about a case where I'm colliding with something. So I want the axis aligned bounding box to overlap the triangle or whatever. You can see that I've colored it purple when I believe it to be enclosing the origin, and you can see here. So this is like a visualization in that sense of the Minkowski. I don't remember how I pan. There we go. So you can see that this is a visualization of the Minkowski difference in this case. It's taking the Minkowski subtraction, right, or Minkowski difference of the triangle and the axis aligned bounding box, and then it's looking to say, well, does the convex hull of this thing enclose the origin? And we, because we're humans, can see pretty clearly that it would, right, if you took the convex hull of these points. But that's exactly what GJK purports to do, right? And so you can imagine why I was wanting to look at that. So there you go. Now, similarly, like I said, these sliders were all on some things. You can see that in this case, we've got a, what is that, like a Y-plane there, I guess. So, I think if I tweak this, yeah, you can see it kind of does some changes to like what the what the viz is showing. So you could tweak those out. Like maybe I don't want to see that, maybe I don't want the grid in there or whatever. And so, those were just ways of kind of tuning the viz. And then if you take a look at these things, you can see that there's, whatever they were, each of the visualizations itself, you could sort of throw in, little things that would adjust what was going on. I don't know what pincushion length was meant to do. Can't imagine what that was meant to do. Pincushion. Is that changing anything obvious? It might have been something that I got rid of, but I don't see anything changing it, so I don't know what that was meant to do. Voronoi length doesn't look like it does anything here, so I don't know what those are meant to do there at all. These points are just readouts of the manipulators, so if I was trying to debug something, I might want to see that, obviously. And all that stuff. I think this supports the same stuff that we support in in Handmade Hero for drag and drop. So you can do crap like that. I don't know that that's very interesting though. So in culling, I don't know what this one was supposed to do. I suspect, so what I'm guessing, and I don't know for sure, but what I'm guessing is that what was supposed to happen here was there's probably supposed to be a data file that this would have loaded, and it would have told us a bunch of stuff about this, right? So we would have loaded something in, and it would have shown us like there would have been a mesh that would have gone with it. And so I suspect the reason that one isn't doing anything is because of that. So hopefully that makes some sense. So again, that's just like a simple test bed, and I would just always throw things into that test bed. I had like the curve fitting stuff in there at one point. I had 2D viz stuff in there. I had a pose-based deformation one in there. Just lots and lots of stuff, and that's where I would always prototype things. So hopefully that answers. Hopefully that answers that question a little more cleanly for you in practice. All right. I don't know what is. Oh, and here's the. Okay. So now that my head has disappeared because we're out of time as well, I realized this probably was also showing an inset render. Probably, that's what that was doing. Yeah. Anyway, yep. There you go. So that was MathViz, and like I said, that was used for basically all of the algorithms in Granny at some point were probably, if they were non-trivial, they were probably prototyped in MathViz at some point. So, yeah, so that's it. There we go. I'm probably going to wrap up now, but that's how that worked. Andrew Russell, that was really awesome to see. Thanks. No problem. Again, thanks for writing that blog post. I really enjoyed reading that, and I think a lot of people on Handmade Hero are pretty interested to see that as well. So I think that was a really great thing. If you have any more blog posts like that you happen to write up about interesting 2D stuff you're doing on RCRU, that would be great. I'd love to tweet those out to everyone so that they can check them out. Alrighty, that's it. Is it for today? Let's close it on up. Close it on up. All right, thanks everyone for joining us for another episode of Handmade Hero. It's been a pleasure coding with you as always. We are almost, we're struggling along like with the sorting. I think we're getting a little more under control, but I'm kind of happy because as soon as we finish this sort of Z stuff, that kind of puts the renderer to bed structurally in a way that I'm pretty happy with, because it means we don't have to think about the Z anymore, which I wasn't liking. We never really had it in a place where I was happy with it, and so I think this will finally turn the crank for us to the place where it's like, okay, now I'm a little happier with the way that we're processing the Z. So we'll keep at it. We'll do it again tomorrow, and then I think next week if we're lucky, next week will be the week where we can finally finish up the sort of our Z conceptualization. If we're lucky, you never know. Until then, if you want to play around with the source code at home, obviously you can always pre-order the game on handmadehero.org. Comes with the source code if you want to play around with it. We also have a forum site you can go to ask questions, a Patreon page if you want to support the video series, a schedule bot if you want to know when we're live, and a past episode guide if you're trying to catch up on old stuff. I will be back here tomorrow, same time, I think, 5 p.m. Pacific, daylight time for the last stream of the week. Hope to see you there. Until then, have fun programming, and I'll see you guys on the internet. Take it easy, everyone.